Welcome to lesson 3.4, solving equations with variables on both sides. So we've already looked at one-step equations and multi-step equations, but in all those circumstances, the variable or multiple variables for combining like terms were on the same side of the equal sign. Now in this lesson, we will be looking at linear equations where the variable is on different sides of the equal sign. So the way that we deal with that by having the same variable on different sides of the equal sign is we collect the variables on one side of the equation before solving. So more simply put, you move one of the variables to the other side by adding or subtracting. And what you're adding or subtracting is that variable plus the coefficient in front of it. So we'll look at a few examples to make sense of that. So all of these, again, are linear equations, and it's the same variable, so we're only dealing with one variable. So in example 1, it says solve each equation. So in A, 7x plus 19 equals a negative 2x plus 55. So we want to get all the x's to the same side. Now, usually what I look at is which way can I go to keep it a positive variable, but honestly, it doesn't matter. If I wanted to add 2x to each side to cancel out the negative 2x, I could do that. Or if I decided to subtract 7x from each side to get rid of the positive 7x, I could do that. But what I look at is which way can I go to keep my variable positive. So in this case, I'm going to undo the addition of the negative 2x. So if I have a negative 2x, I want to get that back to 0x, or 0. So I would add 2x to the right, and whatever you do to the right, you must do to the left-hand side of the equal sign. So we're adding 2x to the 7x, combine like terms, and we have 9x. So then what we have is 9x plus 19 equals 55. Subtract 19 from each side, and you have 9x equals 36. Divide both sides by 9, and x equals 4. So after you get the variable to one side, you're doing what we've done for the last 3 lessons of using inverse operations to isolate the variable. So in B, we have 80 minus 9y equals 6y. So in this case, I want to undo the subtraction of 9y by adding 9y to each side. So my negative 9y and positive 9y cancel, and on the left I'm left with 80 equals, and on the right 6y plus 9y is 15y. So 80 equals 15 times y. Divide both sides by 15, and y would equal 5 1/3. So 80 divided by 15 is 80 over 15, or simplified, 16 over 3, or further simplified to the mixed number from 16 over 3 to the mixed number of 5 1/3. So this, again, is why you don't want to rely on your calculator for division. You should set it up as a fraction, 80 divided by 15, or 80 over 15, and then simplify, and you should end up at 16 over 3, which you could convert to 5 1/3. In C, we have 6x plus 22 equals a negative 3x plus 31. So I want to get all the x's to one side. And in this case, I'm going to add 3x to get the negative 3x up to 0. And then add 3x to this side. So 6x plus 3x is 9x. So we have 9x plus 22 on the left equals 31 on the right. Then I'm going to undo the addition of 22 by subtracting 22. And we have 9x equals 9. Divide both sides by 9. And x equals 1. In D, we have 64 minus 12w equals 6w. So in this case, I want to get all the w's to one side. So I'm going to add 12w to each side. Then I have 64 equals 18w. Divide both sides by 18, and w equals 4. Now in example 2, we have the distributive property first. Then if we can combine like terms, we would do that. And then we want to get the variable to one side and then isolate the variable. So we first need to use the distributive property. So in A, we have 3 times the quantity x plus 2. So the distributive property, you take 3 multiplied by each part of the inside. So we have 3 times x, or 3x, plus 3 times 2, which is 6. So then we have 3x plus 6 equals 3x plus 6. We want to solve for x, so we would subtract the 3x from each side to try to get our x's to one side. Well, that would leave us with 6 equals 6. If we ever have a number equal to itself, what that tells us is all real numbers are solutions to the equation. So if your variable completely cancels, like it did here, and then a number equals itself, that tells us that the solution to that equation is all real numbers. So that means no matter what I put in for x, as long as it's a real number, this equation would be true. And then if we look at part B, we want to distribute first. So 2 times the 3x, and then 2 times the positive 4. So we end up with 6x plus 8 equals 6x plus 9. We could subtract 6x from each side, and we're left with the 6x canceling in both places. So on the left we have 8, on the right we have 9. 8 does not equal 9, so if the variable completely cancels on both sides, and you're left with a number equaling a different number, that tells you there is no solution to that equation above, or no real solution. So, like it notes here, if the variables cancel and the equation's true, our answer is all real numbers. If the variables cancel and the equation is not true or false, then it is no solution. So here, just summarizing everything at this point we know about multi-step equations. So the first thing you want to do is to simplify both sides of the equation, which means if you have to use the distributive property, you do that, and then you combine like terms. The second thing you want to check for is your variable on one side? And if it's not, you want to get the variable to one side of the equation. And third, you want to undo the addition or subtraction. And then fourth, we're undoing the multiplication or division. So looking at example 3, A and B, we're just simply solving the equations. So first we're checking to distribute and then combine like terms, which is simplifying each side. So on the left, we're distributing the 4. to 1 minus x, so 4 times 1, and then 4 times a negative x. So that becomes 4 minus 4x, still plus that 3x on the left. On the right, we're distributing a negative 2, so negative 2 times x is a negative 2x. Negative 2 times the positive 1 is a negative 2, so that is a 2x, or a negative 2x minus 2. Then we want to combine like terms, which we can do on the left, which is a negative 4x plus a 3x. Negative 4x plus 3x is a negative 1x. So we're left with 4 minus x, or 4 minus 1x. And then on the right, we still have the negative 2x minus 2. Then we want to get our variable to one side. So add the 2x to each side, and we're left with 4 plus x equals a negative 2. Get rid of the 4 by subtracting 4 from each side, and x equals a negative 6. And then in B, we're distributing in the left-hand side everyone's favorite thing, which are fractions. Should be your favorite thing, but for some reason, not for a lot of students. But we have 1/4 multiplied by 12x plus 16. So we're distributing the 1/4. So the easiest way, if possible, to distribute a fraction by multiplying, it would be 1/4 times 12 over 1. So 12 divided by 4, which is 3, multiplied by the 1 on top, which would just be 3 still. So 1/4 of 12, which is 3, so 3x. Then 1/4 times 16. 16 divided by the 4 on bottom. So 4 multiplied by the 1 on top, still 4. So the left-hand side after distributing is 3x plus 4. On the right, we have 10 minus 3 multiplied by x minus 2. So we're distributing a negative 3 to the x minus 2. So a negative 3 times x is a negative 3x. A negative 3 times a negative 2 is a positive 6. So we have 10 minus 3x plus 6. Combine like terms on the right. Positive 10 plus 6 is a positive 16. So we'd have 16 minus 3x. And on the left, we still have 3x plus 4. We can add 3x to each side, giving us 6x on the left plus 4 equals 16. Subtract 4 from each side, and 6x equals 12. Divide both sides by 6, and x equals 2. And then down to our final example, dealing with a word scenario. So what the word scenario says is a store charges $8 to rent a video game for 5 days. As you can tell, this came from an old book scenario. Still, video game rental places existed. So a video store charges $8 to rent a video game for 5 days. Not a bad deal. You must be a member to rent from the store, but the membership fee is free. Then a video game club in town charges only $3 to rent a game for 5 days, but the membership in the club is $50 per year. Which rental plan is more economical? So economical would be more cost effective, or which one is better bang for your buck? So the store, if it's $8 per game, and that's a 5-day period, we also know the club's rentals are 5 days, so we don't have to worry about that being a factor. So then we're just looking at the cost. So on the store, it's 8 times whatever number of games you rent. So that would simply be 8x, or whatever variable you want to use. For the club, it's $3 per rental plus the $50 fee per year. So we'll look at what would be the better economical plan each year. So every 1 year. So in this case, the club would cost you $50 no matter what, plus $3 per rental. So what we can do is figure out when we would break even, meaning when would the store plan equal the club plan. So we would take 8x, our expression for the store, and set it equal to our club, which is 3x plus 50. Then we'll solve for x, so we'd subtract 3x from each side, and 5x equals 50. Divide both sides by 5, and x equals 10. So what that tells me is with 10 rentals, the two are equal. So the answer to this word scenario would be with 10 game rentals, you would spend the same dollar amount at the two locations, at the store or the club. Under 10 rentals in a year, and the club isn't a better deal. But when you consider there being 52 weeks in a year, and if each rental is 5 days, that would only be about 10 weeks roughly, not even, that you would be renting different games. So most people that are going to spend money on a membership to a club would rent more than 10 games in a year. So then the club's rental plan would be more economical when you consider that factor. But otherwise, under 10 rentals, the store plan is better. More than 10 rentals, the club plan is better. So the main idea can be summed up into this summary of steps here. Here for solving multi-step equations. First thing being simplifying both sides. So you distribute combined like terms, get the variable to one side, undo your addition or subtraction, and then undo the multiplication or division.